Hey gang, welcome back. 6-3, binomial radical expressions. Remember, binomial just means two terms. So once again, we're going to be trimming this down and only focusing on, what's really going to be important to you guys, like going forward, after your Algebra 2 days are done, which is fairly soon, isn't it? But so add or subtract if possible. Yeah, I'm going to be skipping this basically. I mean, for example, if you had 3 root 2 plus 5 root 2, the way this would combine is it would be 8 root 2. It's kind of like doing 3x plus 5x. You can only add like terms or like radicals. So again, this would be 8 root 2. Okay. Similar deal, except making it a little more complicated. First simplifying stuff, and then, because right now, look, root 12 plus root 75, these do not add the way they are written right now, nor would either of them combine with root 3. It's got to be the same root to be added together. Like here, it was both root 2 and root 2, so this became 8 root 2, but this would not add up until you simplified and stuff. But anyway, not focusing on that. I do want to focus on this stuff. And a little more later, I want to focus on this, and I want to focus on the next, chapter of rationalizing denominators, like the next level, maybe I should say. So check this out. We have a binomial times a binomial. So how are you going to multiply this bubble times this bubble, where this bubble has a couple of terms and this bubble has a couple of terms? Well, good thing is we've done this kind of thing before. And the way we did it was through the distributive property. And a lot of people, teachers, textbooks, whatever, refer to this exact scenario as FOIL. Remember, all you're doing is you're really just distributing, as you're doing all the distributing you have to do. But a lot of people refer to this as FOIL. So 4 times 5, that's just 20. And then we got to do 4 times 4 root 2. 4 times 4 root 2. Okay? Well, to do that, you can multiply the 4 times the 4, because again, this is like 4 times 4 times root 2. You're not going to multiply the 4 to like both of these, even if you could. Like, you can't even multiply a regular number to a square root. But so the 4 times the 4 is all you can do, and that's going to be 16 root 2. And then now we're going to distribute this 2 root 2. So 2 root 2 times 5, 2 root 2 times 5. Likewise, we can do this 2 times the 5, and then the root 2 is attached along for the ride, okay? So plus 10 root 2. And now finally, we do 2 root 2 times 4 root 2. And to do 2 root 2 times 4 root 2, the 2 will be multiplied with the 4 to get 8. And then the root 2 times the root 2, we can do that multiplication. Root 2 times root 2 is really root 4, but ultimately that's just, root 2 times root 2 is just 2. So this can be cleaned up a little bit. First of all, 20 plus, okay, what this really is 16. 8 times 2 is 16. So 20 plus 16 is 36. And then these two middle terms will also combine as they are like radicals or like terms. So 16 root 2 plus 10 root 2, that'll get us 26 root 2. So once again, 16 root 2 plus 10 root 2 is 26 root 2. And that, people, would be your final answer. Let me just clear some more space. This one's going to be very, very, very similar, okay? So we do all the distributing. So that's going to get us 15. 3 times 5 is just 15. And then 3 times positive root 7, well, that's just 3 root 7. And then we got to do the negative root 7 distributing. So negative root 7 times 5, well, that's just going to be negative 5 root 7. Okay? And then we got to do negative root 7 times positive root 7. Well, that's going to be negative, first of all. And remember, root 7 times root 7 ultimately is just 7. And now you clean this up. So the 15 and the minus 7, that's going to be 8, I do believe. And then the positive 3 root 7 minus 5 root 7, those are also like terms, will be minus 2 root 7. And that's how that goes. Okay? So again, the good news is multiplying a 2-term bubble times another 2-term bubble. We've done this type of distributing before. A lot of people refer to it as FOIL, as a memory trick. And then I want to again take like the next step, the next level up in rationalizing a denominator. So here's how this works. So last lesson, last section, we were just doing things like, what if it was like 5 over 3 root 6? You know, in order to do something like that, all we would have had to do is multiply top and bottom by root 6. And that'll get the job done. But here, you see this denominator? You see how this denominator has 2 terms? That ups the ante a little bit. That's a poker reference. But it ups the ante, okay? And what you multiply by, you know, you got to take like a little bit of a more advanced strategy. It's not too bad, you'll see. So, long story short, if you have a denominator like this, where there's 2 terms, and you have to rationalize it, what you're going to multiply by is what's called the conjugate. All right? So, multiplying the bottom by root 5 minus root 2, just trust me on this, that's not going to get the job done. What you have to do is multiply by the conjugate, which would involve multiplying it by, so the conjugate of root 5 minus root 2 is basically root 5 plus root 2. That is what's going to get the job done. And of course, whatever you multiply to the bottom, you also have to multiply to the top. All right? Now the top, this will be, you know, pretty straightforward. You're going to have to multiply this whole numerator times this whole numerator. That's going to involve your basic distributive property. And so 3 root 2 times root 5, well, I can't really multiply the 3 to anything. So root 2 times root 5, that's going to be, so I just have the 3. And then root 2 times root 5 is root 10. And then 3 root 2 times root 2, well, okay. So once again, the 3 doesn't have anything to multiply by, but root 2 times root 2 is just going to be 2. Or again, if you want to think of it first as root 4, but root 4 is just 2. All right, so now the bottom, jeez, You know what? I can't do this anymore with these horizontal lines. All right, much better, I guess. So now on the bottom, what's gonna need to be done is that FOIL type thing. Okay? Now watch how this just works like a charm. So root 5 times root 5, well, isn't that just 5? And then root 5 times positive root 2, that's going to be positive root 10. Okay? So now I got to distribute the negative root 2. Okay, so negative root 2 times root 5, that's going to be negative root 10. And then negative root 2 times positive root 2 is going to be minus 2. Now you can see why, like now the plan comes to fruition, right? Now you can kind of see why it needed to be the conjugate, why this needed to be root 5 plus root 2 and not root 5 minus root 2. Because look at what you get here. You get plus root 10 minus root 10, which cancel out. And then you have a denominator, okay, that has no more square roots. This was the only way, basically, to end up with a denominator that didn't have any more square roots. Now, what happened on top? Well, we have a 3 root 10 plus 6. All right, 3 root 10 plus 6. And so I'm going to say that we're done. All right, I'm not going to muddy the waters too much, even though, okay, even though this 3 can actually divide into both of these terms, and you really should do that. Okay, why the heck not? I'll do it. So to take this whole top divided by 3, you would divide both of these terms by 3. And since both of these terms will divide by 3 cleanly, you pretty much should do it. So 3 root 10 divided by 3, that's just root 10. And then 6 divided by 3, that's 2. So this is really the bestest final answer. But again, my biggest concern here is the method you would do, like what steps would you have to take in order to rationalize a denominator like that. All right, so once again, you always multiply by the conjugate. So just really quick, another little mini example, I'll even change color. What if you had like 7 over 5 plus root, let's say, I don't want to make it too big of a number. 5 plus root, 3, okay? What you would multiply top and bottom by would be 5 minus root 3. The conjugate of this is 5 minus root 3, just like the conjugate of this was root 5 plus root 2. So that should set you up. So again, problems like this where you're multiplying bubbles together like this and foiling, and then, rationalizing denominators like this.